So first multiple choice is just asking about the gradient, but be careful that it's asking for perpendicular. So first thing that you would do is just find the gradient, so y2 minus y1, x2 minus x1, and then sub in the points. And then to find the perpendicular one, you could just do 1 on m. Or if you wanted to do this straight up, you could just do minus x2 minus x1, y2 minus y1. Either way is correct, and the answer should be D. So period and domain of this. So things to keep in mind here are the period is kind of to trick you because we know tan is pi, but everything else is 2 pi. So if we try and find the period, it's 2 pi divided by 2 times 2, and it looks like 4 is the answer. So you might think it's D or E, but it's not because 2 pi is for cos and sine, but we're dealing with tan here. So actually what we have to do is pi divided by pi times 2. So the actual period is 2. So that means the only answers are B or C. And then to figure out this, you don't have to memorize the formula. You could just consider a tan graph goes like this. And then this is the period, so we know that's 2. So then the asymptote has to be at half the period, and it has to be plus or minus like one of the periods. So 1k, oh, not 1, sorry, 2k, 2k. So then you can compare that to the answers, and you can see it's technically none of them. But the thing with this here is that this can be any of the asymptotes. So it can be this one, or like the one at 3 as well. So like it could be 3 plus minus 2k or negative 1 plus minus 2k. So you just have to look for the one that ends with plus or minus 2k and like one that corresponds to an actual asymptote. And the one that corresponds here is B because it's got the negative 1 and it matches the 2k. So question 3 is which of the following is true? So since they've just given us a bunch of information, it helps to kind of like draw a graph that you think might be correct. So G dash at 2 is 0. So you could just like draw a flat line or something and call it at 2. And then G dash X for less than 0 is negative. And it's also less than 0 for everything other than 2. So you can tell that if this is true, then at this point, it's going to be a point of inflection because that's what a point of inflection is. So if it's going to be less than 0, then the graph is going to go like this. And now you can just look at the answer options. So local maximum, that's not right. Stationary point of inflection, non-stationary point of inflection, and then there's more than one stationary point. So E could be true, but E cannot be true because this is the only point at which it's equal to 0. So there's only one stationary point. So it's definitely not E, and it's not A or B because we know this is a point of inflection. The difference between a stationary point of an inflection and a non-stationary point of inflection. A stationary point of inflection is when both f dash x and f dash dash x equals 0. But a non-stationary point of inflection is just when f dash dash x equals 0. So when this is true, the stationary point looks like this. So it's like flat. But when this is true, it can look like, it's probably not a good drawing, but kind of like that. Like the stationary point's vertical. I think maybe that's probably not a better drawing, but yeah. So if it's a stationary point of inflection, the point at which it's like doing the thing is the horizontal. So like that's why it's a stationary point because it's flat. But if it's not, then it's vertical. You don't really have to worry about non-stationary points of inflection in methods, but just in case it asks, it's that. So since we drew a graph here and we know that f dash x is 0, then we know it's going to be a flat point. So that's why it's a stationary point of inflection. So the answer is C. So question 4, average rate of change. So that's just f of 4 minus f of 0 on 4 minus 0. And just chuck that into your cas and you should get B. So which of the following is the rule of the transform graph? So if we just do each of the transformations step by step. So first it's dilated by a factor of 2 from the y-axis. And then translated by positive 3 in the x-axis. And then reflected about the line y equals x. So that means y and x swap. So we go from y to 2x plus 3. And then we know these are, it's like almost like a matrix. So this is x dash and this is y dash. So x dash is y and y dash is 2x plus 3. So as we would normally do, we just find the original graph. And now you can sub it in. So this would be y equals 1 on x to the power 3. So just sub in y and x. So x dash is y dash. That's not an exclamation mark. Y dash minus 3 on 2 to the power 3. And if we simplify this, we get 1 on, I'll just take away the dashes for simplicity's sake. So 1 on x to the power a third is y minus 3 on 2. So since it's 1 on x, we can just write that as x to the power minus a third times 2 plus 3 equals y. And then the one that corresponds to that is just a. So the equations of the asymptotes of the inverse function. So if we have a truncus, to find the asymptotes, the easiest way is to simplify the fraction so that it's a proper fraction. So if we have k x plus 1, we have to mimic the denominator. And then we have to rebuild what we had before. So if we expand this, we'd get kx plus k, but we don't want the k, so we take away a k. And then we just do, we split the numerator, so we do k x plus 1 minus k x plus 1. And then this simplifies to k minus k x plus 1. So the asymptotes of fx would be y equals k and x equals minus 1. But the trick in this question is that it's asking for the asymptotes of the inverse function. So all you have to do is swap the numeral. So this is k and y is minus 1. So the answer is D. So question 7, no stationary points. So once you differentiate px, so you get p dash x, you get 3x squared plus 2kx plus 3. So the way you would approach this question is just like attempt as if you were trying to find the stationary points, not if you were trying to find how many stationary points. And then you would see that it's like a quadratic graph, not a graph, sorry, an equation. And then if we want no stationary points, you would just treat it as a quadratic that has no solution. So if it has no solutions, then the discriminant is less than 0, and then you could just put that into your cas and make sure you write k as a variable and then solve for k as well. Or if you want to make it easier on yourself, you could just write k is x. But if you're doing that, make sure you don't get confused between actual x. And then just cas and c. So average value of h over the domain is 0. So if your cas works, that's great because you could just chuck this in here and then just do 1 on 4 minus 0 hx dx from 4 to 0. If that works for you, that's great. But yeah, it didn't work for me, so I had to do it individually. So if you were going to split this up, you would do 0 minus minus 8 integration 0 to minus 8 2x dx, and then you have to add 4 to 0, 1 4 minus 0, that's a minus, ax 4 minus x dx, and then I had to find what this was, then I had to equate it to 0 and solve for a. That's like, if you ever try this and it doesn't work, this should be your immediate next step, because first of all, try this at home and make sure you know if it works or not. So during the exam, you don't have to test it out. But just in case it decides not to work, just straight away split this up into 2 different functions and just do it like that. But yeah, if you solve for A, you should end up with B. If you do it like this and directly solve for A and it still doesn't work, then just find equation in terms of A, and then do A equals X with the given thing, and it swaps all the A's for X's, and then you can do solve for X because sometimes it's works with X but not variables. Anyways, so simultaneous equations, so just find in a convenient form first. So y is 2x minus 1 on m. So if they're having a unique solution, then the gradients aren't equal to each other. So m on 4 does not equal 2 on m. So m squared does not equal 8. So m is not equal to plus or minus root 2. So the answer that corresponds with that is just C. So which one of these works for all of x and y? So as I said before, just use the judge function on your cares. I think for this one, actually, the judge function didn't work. Maybe it was just me. But if that ever happens, then you're going to have to try each of these by yourself, unfortunately. So you're going to have to put one into here and then put it into here and then just test it. And if you're being forced to do that, just start from the bottom up with the answer C. Actually, before you do trial and error, just have a good look at the questions, because sometimes they have like properties that you might not see. Like this question, it kind of looks like you have almost a quadratic form. So you have like x squared plus y squared plus xy, something like that. But yeah, it just might help you consider what might be happening. Because I think in this question, it was important to notice that I think it was kind of like this, and then you had to figure out. But yeah, just like if your CAS doesn't work, just look at the question before you try trial and error. So binomial variable, we have binomial. So that's kind of a trick, because then they give you mean and standard deviation. So read the question first. This is not normal, so you can't just put mu as 6 and sigma is root 5. So if we're using binomial distribution, we have to know what n and p are. So in binomial, mu is n times p, and variance is np minus 1 minus p. And we know what they are, so 6 and 5. And we also have 2 unknowns, so you can just put these into your simultaneous equations. And then if you're doing probability s is greater than 6, again, you want like an inequality, which includes the equal sign. So it's easier to write it as probability s is greater than or equal to 7. Again, that's just in case you end up putting 6 in your CAS, which would be wrong. So you would do 7 to n, which you found here. And then your probability you would also have found here. And you should get C. So now this question is just testing your chain rule. So if we do d cos of 2fx, and then the inside part, so 2fx times the denominator, so still 2fx on dx, because we kind of we've reached the easiest way we can get. So if we differentiate this, it's going to be negative sine 2x, negative sine 2 of fx times 2 of, sorry, my pen is going all over the place. So yeah, negative sine 2x times 2 of f dash x. So the correct answer is D, but I'm pretty sure the answers say it's E or something. It's a bit weird. That's wrong. They have given the answer as this, but yeah, I don't know why they chose E after saying it's this, but D is correct. Just check that in case you got that wrong or something. You might have gotten it right. So yeah. So for this question, we have a probability density function. And the value of A, so it's not giving us any other information, so what we have to use is that integration of ft from A to negative A is 1. And you can just put that into your CAS, and just since A is greater than 0, I'm not sure if, so A is greater than 0 is important for here, because then you know you're dealing with a symmetrical value, and it's not really necessary, because regardless, it would make sense that it was like this. But imagine if A was negative and you're saying that T is greater than A, so T is greater than a negative number and it's greater than a positive number. So it wouldn't really make sense if A was negative, but it doesn't really matter. It's just there. But if you put it into your CAS, you should get A. So question 14. So with these questions, you always want to try and reconstruct what they've given you. because that way you can actually use this information. So we're trying to find how we can construct this from here. So first we have to get rid of this. So we would split it up like this. G on 2 dx plus a for the 0 x dx. And now you can see this is like a whole separate thing. We can integrate that. We don't need anything else. So that's fine. So the problem is really here with the x on 2 and the upper and lower boundary. So if we use Sir's trick where we replace dx on 2, dx with dx on 2, so we do 4 g x on 2. So since we want the same variable here and here, we're going to do d x on 2. But since we've changed this, we now have to change both of these. So it goes from, since this went from x to x on 2, so you've multiplied by half, you have to do the same to the upper and lower boundary, but the lower boundary is 0, so you can just leave it as 0. But since we've introduced a half here, we have to get rid of the half by multiplying it by 2 here. So then it's kind of like we didn't do anything. So then it becomes, if we just simplify it, 8 2 to 0 g x on 2, dx on 2. And now we can use this because as long as you have the same variable here and here, so here and here, this always means the same thing. So just do 8 times 2, it's not 2, sorry, 8 times 4 plus this one, I think came out to, do I remember what it came out to? 8a, so 8a equals 64. So then 8a is 32, and then a is 4. So the answer is B. So question 15. So this is kind of testing your knowledge of functional notation, actually. Not actual, I guess a bit of probability, but it's just saying that it's a discrete random variable and x is only an element of 1, 2, 3. So you know when Sir introduced like functions to us, he said that if the domain looks like this, then it's literally just like points here, like something here, 2 something here, 3 something here. That's like what this function is. So it's not continuous. It only exists at certain points like these. So if we're trying to find, again, since they've not given us any other information, we just have to assume that the addition of these y values is equal to 1. So all we have to do is sub x equals 1, 2, and 3. So a times 1 squared, which is just 1, 4 minus 1, plus 4a, because that's 2 squared, 4 minus 2, plus 9a, 4 minus 3 equals 1, and then just solve for a, and you should get 1 on 20. So I think the notation here might throw you off, or I guess if you're not paying attention. But that's like the only hard part about that question. So question 16 had a couple of things that you have to consider. So the first thing is that it's been reflected in the x-axis, and then the I guess the harder thing to keep in mind was that it's been square rooted. So if we just, the easiest thing to look at would be this first, so minus, so that means the graph's going to be like this. Oh, that's not a good drawing. Kind of like this. So all of the maxima and minima are going to have a negative version of the y value, or if they're already negative, it's going to be a positive. And then the other thing to realize is that this is only ever going to affect x values. So the only change to the y values is that it's being multiplied by -1. So just ignoring this at first, you can just look at your answers and then get rid of the ones that don't have like a negative version of the y value. So any answer that has the same y value is wrong. So you can get rid of A just because of the y values. You can get rid of, is that it? That might be it. Okay, so you can only get rid of A. But other things to look at would be that, again, the root x does not change the y value. So the y value still has to be the same actual value. So that's how you can get rid of C. Because 7 on 4, you shouldn't be square rooting this because it's a y value. And that way you can also get rid of x because, again, it should still be the same value, it should just be negative. So now you're left with B and E. So the thing to consider here is that the function has been square rooted of x. So we know when you have square root x in a function that x has to be greater than or equal to 0. So something in the middle has to be greater than 0 or equal to. So the problem with B is that it's including the local maxima here, which is at a negative x value. So if you did this to the function, you square rooted it, this maxima would not exist because it's not in the correct domain. So you can get rid of B because it would not actually have that second maxima. So then the only answer you're left with is D. And if you want to test the points as well, you could do, so this is written in terms of x dash. So x dash is x, so then x dash equals x squared. But the only problem with doing this before you consider the domain is that you might be tricked into thinking that the maxima still exists, but that it's at 436. So it's always better to consider the domain first, but I guess even if you did it this way, none of the answers would correspond to that. Oh, actually, no, B does correspond to that. So yeah, better to consider the domain before you start doing this. So yeah, just keep in mind that if you square root it, then the other side kind of disappears. So question 17. So sample size. So we know the equation to find confidence interval is p hat minus the z value p1 minus p on n, and then plus the same thing. So 1.96 is for the 95% one, p minus p on n. So if we're going to find the sample size, then we need to know, we can choose either the upper bound or the lower one and just equate it, but we do need to know p. So the way to find p is that it's just the middle value, so the average of these two. So to find p, it's just 0.035434 plus the second values, the higher bound, divided by 2. I'm not sure what that comes to, but just keep it in your CAS. And then just plug that into here or here, it doesn't really matter. And then equate it to the corresponding thing and just solve for n. And just a hint, I guess, is this question is that it's told you that the confidence interval is given to decimal places. And although the question doesn't ask what it's the sample size closest to, you can assume that they've given you like non-exact values of the confidence interval. So it's kind of insinuating that the sample size you get is not going to be an exact value either. So just with that, it's like kind of like just something to keep in the back of your mind to make sure you have your CAS on decimals, which you would probably have it on decimals anyway for probability, but just like for multiple choice if you didn't. It's like easier to do it the first time on decimals rather than wait for your CAS to load and then have to do it again. So it's like just like a small thing, but might save you like a couple of seconds. But the answer is D. So which of the following is not true? So we have two things here, and if you ever get one of these questions where you have a bunch of numerals, but they have like the same inner function, it's a big hint that you're looking for comparisons. So if we integrate f of x, so aemx dx, and differentiate g of x, be minus nx, so then you have a on minus m, e minus mx, equals negative nb on minus nx. You don't have to worry about c's in this case, constants, because as I said before, you can, if you know you're looking for comparisons, then you can ignore the constants because the constants can like add up. If you had c and k, they just add up to be anything. It could be 0 for all we know. We don't really care about them. Or actually, rather, if they did have constants, the constants would have to be equal because that's the only way this makes sense. So you can have constants, but anyways, we're worrying about the pronumerals in the question, so just ignore the constants. So as I said before, comparison. So we can compare two things. We can compare the coefficient of the exponential, and we can compare the inner part of the x value. So we have one is a on minus m, which is, sorry, includes the b, equals negative nb. So we have, if we get rid of the negatives, we can just say a is m and b, and the other thing we have is m is n, m equals n. So if we go through the list, m on n, so m on n, if we rearrange it, it's just 1. So yeah, that's a natural number. So that's not A, because it's asking for which is not true. If we do n on m, so 1 equals n on m. So again, still 1, so it's not B. M squared on n, if we square this, and it's still 1. So again, C is not true. So A on B, so now we look at this. So A on B is m on n. And we know m equals n, and we know that m and n are natural numbers. So if you square a natural number, you're going to still get a natural number. So it's not D, it's not A on B. I mean, yeah. But if you do B on A, you get 1 on mn is B on A. So we know mn is a natural number, but we don't know that 1 on mn is a natural number. And it's like highly likely that it's not, unless m and n are both 1 as well. So it's asking for the one that's not necessarily true. So that makes sense because it could be true if they were both 1, but for any other number, it's not true. So it's not necessarily true. So that's why it's E. So question 19. So this question requires a bit of, just a bit annoying actually. So P is a distribution of a sample proportion of red marbles. So initially the bag contains equal numbers of black and red, and sample sizes of 4 are taken from the bag. So it says sample sizes of 4, but really, it says samples of 4, but really we're just considering like one time. We're just considering one sample. So probability P hat equals 0 is 1 on 33. So to visualize this question, there's actually quite a few things you can do. You can just consider what are your possible p-values. So p-values are your proportion of red. So you could have no red in the sample of 4, so that's 0 out of 4. So the p-values, the proportion is 0. You could have 1 red out of 4, so that's 0.25. You could have 2 reds, so it's 0.5. You could have 3 reds, 2.75, or you could have 4 reds, that's just 1. But the thing is, we don't know how many, are in the total, the bag. So, because we know when we're finding probability, we always want this to be in terms of x. So probability P hat equals 0, we have to multiply this by n, but in this case it's 0, so it doesn't really matter what it is, so it's the same, because n times 0 is still 0, is 1 on 33. And then now we're trying to find the probability that x equals 0 is 1 on 33. So if x equals 0, then we're dealing with no red marbles at all. So that means we chose 4 blue marbles. So how should I write this? So it's kind of like a really messed up tree diagram where you have, so your first picks, so blue, red, second pick, I'll just go up to 2 for now, but it should go up to a fourth one, but you don't have to draw. This is just, I'm trying to show how to visualize it. So for this one, you would have n on 2 divided by n. So this would be half. So I'll just write half, I guess. So you have half blue and a half red. But as soon as you, so here the sample size is n and sample size is still n. But once you take away 1 blue, you now have 1 less in total. But you also have, so you started with n on 2, which is half. And then you took away 1 from that as well. So I hope you can kind of see where I'm going with this. So, and for, if you get a red and a blue, then you still have the original amount, which is n on 2. So like using this kind of logic, you have to find like a mathematical equation that represents the probability that x equals 0. So that would be choosing blue 4 times. So the first time you have half. You just have half because you would have half of n over n. So that like, simplifies to half. I'll just write it as that. And the second time you have half of n minus 1, but you also have a total, you have the total minus 1 as well. So you have n on 2 minus 1 on n minus 1. And then the third time, so I'll just go down here. Third time you have n on 2 minus 2, but you have n minus 2. And the fourth time you have n on 2 minus 3, n minus 3. So that's like if you multiply all these four things, that's the probability that x equals 1, which we also know is 1 on 33. So I think you can see where I'm going with this, is that you only have one unknown now. It's just n, and you can chuck it in your CAS and find what n is, and it comes out to be 12. I think there was the other answer. Your CAS gives you like 3 point something, but obviously you can't have 3 point something. It's too small. You can't choose a sample size of 4 out of a total of 3. But yeah. So question 20. So maximum set of values for which f and gx only intersect once. So if we consider gx first, because I guess it's the more complicated one. So tan x is kind of like this. And we know its asymptotes are x equals pi on 2, x equals minus pi on 2. So that matches with the domain that's given. And we have f equals 2x. So fx is just the line through the origin. So I'll just draw it like this for now. So the way I've drawn it now, you can see we have 3 solutions, which is not what we want. We only want one solution. So if we want only one solution, I'll just draw it again in blue, I guess. So you want it to be either here or like here. Nope. Here. Nope. Wait, what am I trying to draw? That's not what I was trying to draw, sorry. So either here or your graph is so high that it doesn't intersect. So if you see your line is kind of like anywhere from here, the only intersection will be the origin. So the corresponding tails to these graphs will be like this. So you can see like a gradient in these 2 quadrants is completely safe. That's kind of, by just using that knowledge, you can get rid of quite a few answers. You can get rid of A and B. You can get rid of C as well, because if you're going to have a gradient like this, it's going to be negative. So anything that doesn't have a negative in it is wrong. But the other answer you can consider is that when, first of all, we're dealing with A here. So A affects the tan x. So if A is higher, then tan x becomes like more like straighter. So it becomes more taut. So that's what we want. I've been changing the wrong graph. Sorry, we don't want to change tan x. I mean, we don't want to change the straight line. We want to change tan x. So if we have here, we have tan x. The normal graph is like this. We have pi on 2, we have minus pi on 2, and we have 2x. So what we want to do is we want to change tan x so that it's negative. So if tan x is negative, it looks like this. And you still only have one intersection at origin. So again, that's why you can get rid of all these options that don't include a negative. And then the other thing you can solve for is when the gradient of tan x is greater than 2. So it's like, goes like this. So you can see that it still doesn't intersect 2x, because 2x will go over here and tan x will go over here. So what you're going to solve for is, So g dash of x is greater than 2. So a on x squared, x is greater than 2. And then, so sec squared, not a on sec squared, just a sec squared. So sec squared is just cos squared, which is why I think just wrote it like that. So cos squared, if you consider cos squared, the maximum of cos squared is always going to be 1. So that's where you get a is greater than or equal to 2 from. Yeah, so now you've got 2 things to consider. So you know a has to be greater than or equal to 2. And you also know that it has to include a negative value of some kind. So the answer is E. But even if you didn't want to do the whole greater than or equal to 2 because might be confused or something, just consider when tan x is when it's just tan x, so when a is 1, so it doesn't really make sense because if you just do tan x equals 2x in your cas, just if you go down to here and you can't think of any logical reason to get rid of either of them, just do tan x equals 2x for a is 1, and then you'll get multiple answers, and then you'll realize that this is not the answer because it can't include a is 1, and then you could just easily get rid of e if you didn't want to do the whole thing. It's probably going to take you more time to figure this out than to just sub a is 1. But yeah. So short answer question 1. So state the period and range. So the period is that's what's happened. Sorry, my ink is a weird color. So the period is since we are dealing with sine, we can use 2 pi here, half. So that's 4 pi. And the range we know is this plus or minus the amplitude, so minus 2 to 6. F dash x is only 1 mark, so do it by hand and make sure you come back in checking time to do it by cas, or just do it by cas the first time around because it would be a bad place to make a silly mistake. So this one's just chuck into your cas. It might be hard to do this exactly in your cas, but first just solve f dash x equals 0 and then get those values for the given range, and then just graph fx and then see which values correspond to which section. So I think the graph of this looked like this, and then it had pi, 3 pi, 5 pi, and 7 pi. This graph of f dash x. So then the answer would be x is an element of pi to 3 pi union 5 pi to 7 pi. So find the values of a and b. So we have a matrix. So first thing, just expand the matrix. So x dash is x plus pi, and then find normal x, so x dash minus pi. And then y dash is ay plus b. So y is y dash minus b on a. And then sub these into your original rule. So f dash is the transform function. So you're going to sub these into your original rule, which is this one. So we have y dash. I'll just get rid of the dashes, but just know that this is in terms of y dash and x dash. So 1 minus b is 2 minus 4 sine x minus pi 1, 2. So if, I'll just expand this really quickly. It's just 2a minus 4a. I'll take the half out. So x minus pi plus b. So it's y equals 2a plus b minus 4a half x minus pi. So the problem here is that this is our graph of f, and the graph of f dash x is actually, so this is our supposed f dash x, is actually negative 2 cos x on 2. So the problem is that, oh my gosh, I forgot a whole thing here. Sine. So the problem is that we have a sine here and we have a cos here. So this is where you use your unit circle properties. So if we're doing x minus pi, if you just consider a unit circle, so if we have alpha here, this or x, this is your angle here. If you're doing pi minus that angle, so then you're doing this thing. So where's cos here? Cos would be negative, and then you can get rid of the inside part. So basically, you're just taking out this, and you're finding that cos would be negative because cos is what we're trying to convert it to. So since it becomes negative, then this thing becomes positive. So you can rewrite this as f dash x is 2a plus b plus 4a cos x on 2. And now we have it in a form that we like, that we can work with because we just have cos to compare now. We can just compare the other things. So first thing we can compare is the one that's by itself. So 4a is by itself. With minus 1, it's not like together with b. What have I done? I feel like I've missed something. 4a doesn't look like I've missed something. I have, so the 2 here. It's negative 2, so the first thing is 4a equals negative 2, so then a is negative half. And then now we can consider the other thing, which is the constant outside, which is 0 in this case. So 2a plus b, 0, and then b is negative 2a. It's a weird way of writing that. So it's negative 2 times negative half, which is just 1. And then you have your two answers for a and b. So find the equations of the tangent. So this is just a CAS question. So at x equals pi on 3, just put into your CAS and you get minus root 3x plus root 3 pi on 3. And then at x is 13 pi on 3, again, in your CAS, you get minus root 3x plus 13 root 3 pi on 3. And just make sure that the gradients are the same in case your CAS did anything weird. If your gradients are the same, then all should be good. So find perpendicular distance between these tangents. So there's two ways of doing this. The answers used both of them. I personally used the one with the perpendicular. Sorry, that's not a great way of explaining. I just found the normal. I found 2 points, and then I found the distance between them. So the right angle is here. So yeah, it's like x1, y1, and then x2, y2. So then distance is square root x1 minus x2 squared plus, it's probably not a great way of writing that, so x2 minus x1 squared plus y2 minus y1 squared. So that's the formula I use, but the other things you have to figure out are the perpendicular line here, so you can actually find the points of intersection. Since we're dealing with like linear lines, the gradient's going to be the same. So if you know the gradient of the line, in this case we have one of them is minus root 3x plus root 3 pi on 3, and then the other one is minus root 3x plus 13 root 3 pi on 3. So if you're trying to find like the perpendicular line, you can just straight away just use the gradient. You don't have to worry about finding a c, because like no matter how much you move, like consider two lines like this, like, and then you have your perpendicular line, say it's going through the origin or something. Like no matter how much you move this line up or down, like say you moved it to here or something, like it's always going to be perpendicular. It's just the only thing that'll change, it's going to be where it intersects. So for here, I just chose to ignore the c value, just for simplicity's sake. You can find it, but it'll just be like wasting your time, I guess. The next thing is to find points of intersection. So if you correct these two, either one, it's good to remember, or actually both of them, because again, if you chose one and then chose like that point, and then chose to find the line corresponding to that c value, then equate it to the other line. But If you did what I did, then just find intersections with both of them. So equate it here, then equate it here. You should get pi on 4, pi 4 root 3, and then the other one is 13 pi on 4, 13 pi on 4 root 3. So then we just chuck that into the distance formula. You should get 2 pi root 3 units. So question 2. So we have some agar plates. So important things to note here is just it didn't really affect this question, but always keep in mind the like restrictions on stuff. Just if it's in bold, it's important, and like the units that stuff is in, and then you can kind of link the proportion to the percentages, because now you know, like also this one, because like just to generally what you're going to be equating, because you can tell you're not going to be equating PT to 20, you're going to be equating it to 0.2. So show that question. So just put your devices away for show that questions. So it's 1 minus m e to the kt plus m. So the two things that we know are that initially they're 20% covered, and then the other thing is that after 4 days they're 80% covered. So we're going to be doing kind of not really simultaneous equations, because you'll see that if you put in initially covered, then t is 0. And if t is 0 in here, then k is 0 as well. So then you're just dealing with m. So that would be a good place to start if you notice that. So the first thing is sub p0 equals p10 equals 0.2. So 0.2 is 1 minus m e to the 0 plus m. So e to the 0 is just 1. So 1 plus m is 0.8. And then m is 0.8 plus 0.8m. So then 0.2m is 0.8. And then you just see that m is 4. So now that you have m is 4, even though it's to show that, you can use that because you've already proved that. So now you can rewrite pt is 1 minus 4 kt plus 4. Plus 4. The other thing you want to show is that after 4 days, it's 80%, so 0.8. So then let P4 equal 0.8. So 0.8 is 1 minus 4 E4K plus 4. So 4 on E4K plus 4, 0.2. E4K plus 4 is 20. So E4K is 16. And then log rules. So ln 16 is K. K is, the 4 disappeared. It's 4K. Is 4K is, so we know it's 4 squared, so 2 ln 4. So 2K is ln 4, but we know that 4 is 2 squared, so 2K is 2 ln 2. So K is ln 2. And you can sub this one. So sub 1 into, we'll just make this 3. 3, so then P1T is 1 minus 4. So like, you know the log rule, if you put like a log here, so log alpha t, it becomes alpha to the power t. That's what we're using here, so 2 t plus 4. So show that question, so yep. So find average rate of change. So average rate of change is just P14 minus P10 over minus 0, and you get 3 on 20. So find values for which the growth rate is equal to the average rate of change. So let P1 dash of t equal your answer from the previous question. So 3 on 20, and then just keep in mind the interval when you're putting your carries in. It's should make it faster as well as like give you the right answers. And then just also keep in mind the decimal places. And if you do that, you should get t is 0.9 days and t is 3.1 days. So now we have a second plate, and find the value of t for which it becomes a maximum. So just normally how we would find maximum. So let p2 dash t equals 0, and then make sure t is greater than 0, because now we don't have any restrictions on what t can be. And you should get t is 5.2. It's only 1 mark, so minimum working out is fine as long as you get the answer. So find the maximum percentage, so you just sub in your answer from here. So P2 or 5.2, but make sure you keep all the decimal points from here. Just don't round it off for the use in this question. And I got 0.59887. So that's approximately 59%. Again, just keep in mind what they want it. So like nearest integer and percentage. So if you wrote this, it would be a giant waste of time because you got the answer, you just didn't write it in the right form, and they still won't give you the mark. So find the duration of which the bacteria says covered more than 50%. So I think the graph kind of looked like this, and you had 2 values here, and those were so T1 and T2. And if you solve for P2T equals 0.5, I think you get T is 3.15 something, and T is 8.0926 something. So duration of time is just T2 minus T1, and you should get 4.9 to the nearest decimal place. So find time for the bacteria to be eradicated. So that means like they're all dead, so PT is 0. And that's just T is 16.7. Oh, and so now we have a third toxin, and it's asking to find the value of Q and the time taken for the bacteria on the dish to be eradicated. So that's when, sorry, oops. So this is kind of like actually, it's kind of like, where is it? Question A, the shadow question, we had to kind of use simultaneous equations, I guess. Not really, actually, but yeah. So the 2 things we know for this one is that the maximum percentage of the third plate cover is 50%. So it might seem like you only know 1 thing, but you actually know 2 things, because say I'll let M, so I'll just let M be when this occurs. So at T is M, the plate is at 50. So that's 1 thing we know. And the other thing we know is that on the graph of P dash to T, at M, it's going to be 0 because it's a maximum. So using those 2 things, we're going to make simultaneous equations. So one is P3M is 0.5. And the other thing is P dash 3M is 0. So then in your CAS, just do these 2 things. So I think in your CAS will, or at least it gave me P dash T in a relatively nice form. Sometimes you get like things that you can't write down, so it's kind of hard to get the working out marks for those. Minus Q. So just sub this in here, and and let T equal M, and just do this. And then you should get your values of M and T. So M comes out to be like 4.75. I don't think it asked for M, but yeah, you need M because you don't have the equation to find this latter part here. You need the time taken for the third dish to be eradicated, and you also need to find the value of Q. So the value of Q is when you sub M in, or in a simultaneous equation, and that is 0.078. The decimal points, they've said that Q can be up to 3, but the other time value is only 1. So, and then, so now that you have Q, you can put it into here. So then P3T is 1 minus 4 on 2T plus 4 minus qt. Just make sure you replace q with the value you found with all the decimal points, and just let that equal 0, and then t comes out to 12.8 days. So that was question 2. So question 3 is probability question. So now we're dealing with cans of paint. The probability that something is overflowed is 8%, and it's independent of other cans. And then we have 32 cans of white paint. So things that we know is that the probability of overfilling a can is 0.08, 0.8, so 0.08. And since it's binomial and they haven't given us a variable, I just defined a variable. I said let x equal amount of overfilled cans. So we're looking for at least one that has been overfilled, so that's including one. So probability that x is greater than or equal to 1, and then just put that into your cas, and you should get this, where n is 32 and p is here, so it's 0.08. So given that at least one can, so we have a given function here, find the probability that fewer than 4 have been overfilled. So fewer than 4, just be careful that's not including 4. So the probability version of this would be probability that x is greater than, less than 4, given that it's greater than, x is greater than or equal to 1. So if we expand that, actually, the better thing to do before expanding would just to convert this to one that has the equals in it. So probability x is less than or equal to 3, given that x is greater than or equal to 1. So then when we do the intersection, it just includes both terminals, which is much nicer to see and comprehend. So this is your same answer from part AII. And then the top part you're going to have to put into your cas. So again, n is 32 and p is 0.08. And yep, so you just chuck it into your cas and you should get 0.7302. So part B. So now we're doing with normal distribution. So they've given us the mean and standard deviation, and they've also defined what maximum capacity is. Again, probably because we're dealing with overflow. So find the probability that a random selected can of paint has been overfilled. So this is the probability. I did have to redefine a variable because again, they haven't given us any variables. So let V equal volume blue paint. You don't necessarily have to, but it's much better and easier to show the examiners what you're doing when you have a variable to deal with. So probability that V is greater than the maximum capacity, because that's what it means to be overfilled. And just with the mu and standard deviation is 0.0304. So MetaPaint decides to take 200 samples. So that's your n value. It's going to be 200. And we have several proportions. So now you know we're dealing with sampling. So again, as soon as you see like p hat, or like not necessarily the word proportion, because they do talk about that even in normal distribution, but like if you see p hat, that's a great like red flag sampling. So overfilled. So find this. So again, it's kind of like a list of steps if you're doing the sampling. So like 1, convert to x, and then 2, make sure the inequalities have equals in them. So like you want less than or equal to, greater than or equal to. And 3, like just like do what you normally would when you have x. So first thing to do is convert to x. So just multiply both of these values by n. So, and then replace p with x. So we have x is less than 10, given that x is greater than 2. And then now we have to convert this to equals. So x is less than or equal to 9, given that it's greater than or equal to 3. And then now, since we have a given function, we want to get rid of that. So x is greater than or equal to 3. And then now you can just solve this as you normally would, where n is 200. And p is the probability that something's overfilled, which you actually found in part B. So just let p equals 0.0, I think 39 was the full version. 3039. And you should just get 0.909 according to 3 decimal places. So using normal approximation, find the value of b such that probability p less than b is 0.9. So again, just following the steps. First, we have to convert to x. So x less than b times n. So bn is 0.9. And then since we actually have mu and sigma, so mu is 200. So we don't have it, but we can find it. So the expected value is always NP. So NP, so 200 here, and then P is probability value again, so just this one, times 0.0309 approximately, which is 6.07927235. That's what I got when I did it. And then standard deviation is square root NP 1 minus P. It's 2.42755. So just because the question says using normal approximation, don't be confused into not using these because we get them from binomial. We still do use these equations even though it says use normal approximation. This is just letting you know what CAS function you should use. So like, since it says normal approximation, that's why we have to find mu and sigma, because if you were doing binomial in your CAS, you would only need n and p. So yeah, don't think this is wrong. This is still right, even though it's normal approximation. So now that we know mu and sigma, we can just chuck this into our CAS. So probability, so inverse norm of this, and then it would tell you that the inverse norm of this for these two specific things is when NB is equal to, we know what N is. So N is 200, 200B is like 9.190694968. That's like the full decimals that I got in my CAS when I did it. And then just divide by 200 and you should get 0.04602 4 decimal places. So part E, so it's found that there's a mean here, which is 300, and we have the same maximal capacity. And it's found that 5% of green cans are being overfilled. So now we're dealing with green cans, and the probability is 0.05 is overfilled. So I'll again define a variable. So let G equal volume of green paint. So then the probability that G is greater than 315 is 0.05, as it says here. So then, since we're trying to find standard deviation, if anything is missing, like standard deviation or mu, the way you have to go is standard normal distribution. So just find the same probability value, and you need to find the little z value for which this occurs. So I got 1.64485 approximately, which gives the same probability. And then now you can convert between these two values. So z is x minus mu on sigma. So sigma is x minus mu on z. Sigma is, so x is 315 minus 300 on z, which is 1.654485627 something. And then sigma is just 9.1194 to the nearest 4 decimal places. So now we have a sample of 50. And we have proportion of cans that are filled with less than 300 ml of green paint. So they're inspected one at a time. So that means they are in fact replaced. So like taken, put back into the sample. So like N remains 50. So find the probability that the first can is that's found to have less than 300 milliliters is the fourth one. So as I said before, don't be tricked into thinking that just because it says proportion, it's sampling. This is not sampling. This is just still normal binomial distribution. Sorry, not normal, like just like the usual standard distribution in binomial distribution. It's not a great way to word it, but yeah. So the what was I going to say? The probability. So now we're trying to find the probability that they're less than 300. So if you recall from here, 300 is actually the mean. So the probability that the volume of a green can is less than 300 is just half, because 300 is mu. Again, this half thing only works because it's standard normal distribution. If you're dealing with like discrete probability, don't just automatically assume it's half, or probability density functions don't assume it's half just because it's greater than or less than mu. It only works for standard normal. So probability that the first that's less than 300 is the fifth. I'll just write it like this. Is that so? The first one's normal, second one's normal, third one's normal, and then the last one's normal. They all happen to be half, so it doesn't really matter. And that's 1 on 16. So determine 95% confidence interval. So the confidence interval now is p hat minus. So anytime it's a confidence interval, it's like it's asking for sample proportion. So confidence intervals will always be in terms of p hat, because it's usually it's literally asking for like confidence interval about samples. So that's why it's always involves sample proportion. So we need to know p hat and we need to know n. So we know n is 50, and p hat is the amount of affected individuals in the population. So there's 36 cans which are affected in a total can of 50, so that's 0.72. So they just chuck these values in, and you get 0.5955 and 0.8445. So now we have a probability density function. So find the expected volume. So ER is 310 to 250 RFR. This question was really funky because it asked for whole numbers, but I'm not sure if it was just my CAS, but it didn't give me whole numbers, which was really annoying. And I'm pretty sure it didn't work at all in main. So what I did was in your graphing menu, I just like found what not FR. So I just like wrote what FR is, and I expanded it, and then I graphed it like this. And then in your menu, there's like a thing called integral. So it does the same thing as this, but it's always in decimals. So I just did that, and I found the area in decimals, which is not the greatest thing to do since it asks for exact values, but like it wasn't working at all. So that's what I did. And then it conveniently turned out to be 28.3.333. Sorry, 3.3 recurring, so that I knew that was a third, so that I could convert this to an exact value, which happened to be this, which was correct. But like if you're ever like your CAS just doesn't give it to you in decimals in the exam, I think maybe just leave it for now, just write it in decimals, and then later come back and see if you can convert the decimal to a fraction. Otherwise, like you can't really do much if your CAS doesn't work. But yeah, sometimes you get lucky, like in this question, and you can convert it even if your CAS didn't work. So standard deviation we know is just so the variance, not the variance, so R squared FR minus DR minus the square root of the expected value. So not the square root, the squared expected value. So this one. And again, same problem here. I could not integrate this on my CAS. And the what do you call it? The decimal thing, it didn't really work out well. So I left it in decimal, but I think it could have just been my CAS. So if your CAS worked, you should have gotten 10 root 17 on 3. So find the maximum capacity of, given the maximum capacity, is 300, find the proportion of cans that will be overfilled. So proportion, again, don't be tricked into thinking it's sampling. It's not, it's just asking for the probability. So probability overfilled is 300 to 310 FRDR. Again, my CAS in the main didn't work for this, but since it's asking for decimals, I was able to successfully use the graphing menu. So again, if integration never works or doesn't work on your CAS, always use the graphing menu because the graphing menu always works. Graphing menu is amazing. It'll give you a value no matter what the function is. So if it's a 2-mark question, you'll always get your answer for working out. But yeah. So question 4, so it's just a parabola, and we know how to graph parabolas. It's just like this. And then make sure you graph your endpoints, 0, 4, 4, 0. Just in graphing in general, it's always good to have at least 2 points on the graph. It's like a rule of thumb. So find rule and domain of f inverse x. So let fy equals x, then x equals 4 minus 1 on 4 y squared. So 1 on 4 y squared is 4 minus x. Y squared is 4 minus x. Y equals plus or minus 2 square root 4 minus x. And then when you're considering whether it's plus or minus, just the range of this has to be the domain of fx. So the domain is from 0 to 4. So since the domain is always positive, the range of f inverse x is always going to be positive. So that's why you choose the positive. And then the domain of f inverse x is going to be the range of fx. So the range of fx is 0 to 4. So it's 0 to 4, both inclusive. So find B, the area enclosed by this. So B, so usually you can do x minus fx or something like that. But in this case, I think it looked something like this. This is a super bad drawing. What's it? Okay. Not sure how to draw this better, but basically since you have it like this, you can't really do something minus x times 2. Actually, yeah, you could do fx minus x times 2 because this area is the same as this area. No, you can't. Yeah, no, you can't use x in this case because you want this area, not the area under the graph for either one. So in this case, you actually have to do integration of fx minus f inverse x. The first thing would be to, find the points of intersection. So let fx equal x, or you can do f inverse x, doesn't really matter. You get 2 root 5 minus 2 and 2 root 5 minus 2. Again, never worry about having to find the y value because it's going to be the same as x value because it's on the y and y equals x. So to do B, you do 2 root 5 minus 2 to 0, fx minus f inverse x, dx, and then 4 to 2 root 5 minus 2, f inverse x minus fx dx. And that comes out to 80 root 5 minus 176 on 3 units squared. So rectangle, blah, 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 find the expression for the area. So it always helps to draw a mini diagram. So we have the rectangle 0, 0. It's going to be 0. Nope, it's going to be M0. It's going to be 0 FM. It's going to be M FM. So now you can kind of visualize where the points they're talking about are. So this is 0. This is K, this is N, and this is N. So the area is just going to be M times Fm, because it's going to be this, which is Fm, times this, which is M. So if you put M into the quadratic we saw before, it's just this. And then find value of M for its maximum. So just do A dash M equals 0. You get M is plus or minus 4 root 3 on 3, but we know M is an element of 0 to 4. So M cannot be negative, so it's the positive version. And in the next area, you can just sub in what M is. So 4 root 3 on 3. And that comes out to 32 root 3 on 9 units squared. So let S be the area enclosed by fx and the coordinate axis. So it's just the area of the graph of fx. So S is just 40 fx dx, which is 32 on 3 units squared. So AR on S is 32 root 3 on 9 divided by 32 on 3, so just times by the reciprocal. And the 32's cancel, and you can get rid of this, so you get root 3 on 3, but we want it in the form 1 on root A, and we know 3 is just root 3 squared, so 1 on root 3. So part D. Verify that these points are on the graph. So if it asks for verify and not show, you can actually use the solution. So you could just sub in G0. So that's 4 minus 4, 0 and 4 to the power K equals 4 minus 4 times 0, which is 4. So just with show that questions, even if they're only 1 mark, it's always best to write as much as you can, just because you never know what the mark is for. So the second part is that G4 is 0, so 4 minus 4, 4 and 4, K, so 4 minus 4 times 1 to the K, 4 minus 4, which is 0, so that's a 4, sorry, G4 equals 0. So like here, you would kind of try and show that you understand 1 to the power anything is still 1. That's like, yeah. So TC is a rule that gives the area of the trapezium. So we know the area of the trapezium is the average of these two sides plus the height. So TZ is, so 4 is this one, and GZ is this one. 4 plus GZ on 2 times Z, so that's the height. So TZ is, I'll just take out Z on 2. 4 plus, so now GZ is 4 minus 4, Z on 4 to the power K. So TZ is Z on 2, 8 minus 4, Z on 4 to the power K. And then if I multiply everything out, so TZ is 4Z minus 2Z, Z on 4 to the power K. You might want to add a step here where you like multiply everything by half maybe, so Z 4 minus 2, Z to the power K, 4, 1K. But yeah, so yeah. So question, part F. So show that ATK equals 16, this thing here. So the first thing to notice is that you've gone from a function of Z to a function of K, and that AK is the function of the maximum possible area. So that's kind of giving you a hint. So the way to do this question would be to just find like the maximum of TZ. So that's like the way you would approach this question. So you have TZ, which is 4Z minus 2z, z to the power of z. Sorry, z. Oh, I just write this again. So tz is 4z minus 2z, z on 4 to the power k. So if we are approaching this to just find the maximum, we do t dash of z, which is your calcs will give you 4 minus 2 z to the power 4k minus k z on 2 z to the power 4k 1 minus k, sorry, 1 minus k. And if you consider that, like when you're doing, when you're trying to find the maximum, you would equate t dash z to equal 0, so 0. And so like, since we have this thing here, oh gosh, I just rubbed it all out. So since we have this thing that we don't really want, not the 4, here, so the whole z on 4 thing, we want to try and factorize that out. So if we take it out, it's going to be k plus 1, z on 4 to the power k, which equals 0. And then now you can see that you have it in a really nice form. So I'll just get rid of the equals here. So 4 equals 2k plus 1, z on 4 to the power k. So usually if we're trying to find like a maximum, we want to find the z value for which it's the lowest. So we're trying to rearrange this to find z. So 2 on k plus 1 is z on 4 to the power k. So then z on 4 is 2 on k plus 1 to the square root of k. So I'm just going to write as 1 on k. And then z is 4, 2 k plus 1 to the power 1 on k. And then now you have your z value. So again, to find max area, usually we would sub this back into here. So we're doing, let's just call that z1. So we're doing tz1, which is 4 times 4 to k plus 1 to the power 1 on k minus 2 times this 2k plus 1 on k times this to the power k. So 4 to k plus 1 1/4. That's kind of an annoying question because there's a lot to write and it's to show that, so we can't really skip any of the steps. But yeah, just make sure you expand this, and once you expand it, you'll get the answer, which is ATK, which is 16k k plus 1, 2k plus 1 to the power 1 k. So find the smallest value of p for which this is less than p for k is greater than 1. So the questions are worded a bit trickily. So it's asking for the smallest value of p, but what it's actually asking for is the maximum value of the area. So it's 1 mark, and that should hint you that, and given that there's not a lot of working out space, it's not actually a question that's meant to be done mathematically, I guess. I mean, you could, the answers have a way where you can do it mathematically, but the best way to think about this question is that we're dealing with a trapezium, and the maximum value, if you're given a quadrilateral, is always going to be a square. A square will always give you the maximum value. So like, just with that knowledge, the maximum value of this is going to be when z is at a value where z is equal to 4. So at that point, the max area is going to be 16. That's really it. You don't even have to explain this in your working out because it's only 1 mark. But just if you're dealing with a question where it's asking, I think we've had a couple of these same questions before, where it asks you for a maximum value, and there's like every time it's easily done by just looking at the graph. So yeah, just notice that Just notice like which shape it's aiming towards. Like that's kind of where it's going. It's kind of hard to explain, but just observe the graph, I guess, and see like what possible shapes you could get by changing the z and x values. But the answers do have the option. If you want to do it completely mathematically, you get the previous equation, so the one where you have area here, so you get AK 16k, k plus 1, 2k plus 1, 1 on k, and then you just do limit k to infinity. If you can't like sub it in and think about what it would do with algebra, you can use the CAS function. The CAS function works just great, and that should give you 16 as well. So find the area of the region enclosed by G, and the coordinate axes. So it's just so coordinate axes, you first have to find like the x-intercept. So just let gx equals 0, and then when that happens, x equals k. So then you can just do integration k to 0 gx dx, and that comes out to the area is 16k on k plus 1 units squared. And that makes sense because it's asking for in terms of ka. So find the value of k for which t on a is a minimum, and hence find the area of trapezium. So the first thing is find what at on a is. So that's 2 on k plus 1, 1 on k, because 1 on k. So you can see that like if you compare this and this, this and this, like you've just gotten rid of this here. So it's just this part. And then, so the minimum value of, the minimum value of this is just when, like, do it in your CAS. So, like, redefine this as fx, not fk, sorry. And then just do f dash k, 0, and then sub that k1, so fk1. And that's the minimum, so just 3.3. I got 3111. I actually got 3110705, but it's asking for 4 decimal places, so 3.3111. And then it says hence find the area of the maximum size trapezium for this value of k. So, like, even if you didn't understand why it was saying that, since it's saying hence, you can safely assume that for this same, for this k value, that's where you get the maximum of the area. So, like, it's asking you to find the maximum value of this. This is a function of k, and you found a k value here. And, oh no, sorry, here, wrong value. I didn't write what the k value is. Oh wait, no, my bad. This is the k value. So, sorry, when you solve f dash k equals 0, k is this. So you have a k value here, the other function requires a k value, and that gives a max. So you can safely assume that subbing this in is going to give you your maximum area, which it does. And yeah, that's the paper. I hope that last question made sense. Sorry.